Hi, welcome to a new session of control systems. From today onwards, we are going to see some basic of control systems, especially which are asked for external exams as well as competitive exams. So we'll see all the techniques which are involved in control systems. We'll start with block reduction technique. This is a basic technique to obtain the transfer function of a given physical system. So what is this block reduction technique? What are the rules of block reduction techniques? And later on how we can solve any transfer function using different techniques you are going to see in coming control system classes. So we'll see the rules that is called as basic rules of block reduction. So rule number one, combining the blocks in cascade. So you have seen these kind of blocks arrangements in different control systems X. So you have a block G1 and block G2 where a parameter A is multiplied with G1 when you're going to get the series value as AG1 that is taken as input to G2 and the final output would be AG1 and AG2. This is one important rule. That is a rule number one followed in block reduction. For this arrangement, it can be directly done or reduced to this reduction as A, that parameter. Uh, Series blocks G1 and G2 are directly multiplied here and output is taken as A, G1, G2. So this is how we combine the blocks which are in cascade. So this follows under rule 1. What is rule 2? Rule 2 is the combining the blocks in parallel. What is that blocks in parallel? Now you can see here G1 and G2 are the two blocks which are arranged in parallel and they are summed up with the help of a summing point where A is the parameter which is going to multiply with AG1 and AG2 like this and the final output would be A of G1 plus G2. Now this parallel block arrangement can be reduced further as A of G1 plus G2, which will be getting the value as A of G1 plus G2. Likewise the same case with the rule number 2. In the third rule, which is the one of the basic and important rule apart from series connection and that was cascade connection and parallel connection. This is a very important rule. What is that? Moving the branch point ahead of the block. What do you mean by that? Now you see you have a block G1 multiplied with parameter A. The output is AG1. Now I have to move this branch point ahead of G1. Means what? This branch point which is on the left side of G1 has to be moved on to the right hand side of the G1. Then what is the rule I should follow? Here you see when A is taken from the input side, the output is A itself. So this alteration you should keep in your mind that A when multiplied with G1 you're getting the value as AG1 whereas A is taken as it is as A. Now how this alteration has to be done? So for this the rule is framed as see A multiplied with G1 it is AG1. Now this A I should get over here. So what I'm going to do, I'm going to shift this point, shifting point from left of G1 to right of G1 by taking the output as AG1. What I should do in order to get the value of A, I should divide this AG1 by G1 so that I'm going to get the value of A as it is without any alteration. So you have observed how a branch point is moved from left to right and keeping the mind that uh, the result of the input is A as it is. So you can see the result of input is A as it is, whereas the output AG1 it is taken and it is divided by G1 in order to get this value A as it is. So this is one of the major and important rule of block reduction. Like this, we have a set of 2 to 3 other rules which we need to keep in our mind. Overall, you may have 10 or 12 rules, but here I have combined them as some 10 rules. The rest of the rules you can easily follow. Uh, Let us go with another rule. And what is the conclusion of this rule number 3? That branch gets divided by the block parameter after shifting from left to right. Okay. Okay. So rule number 4 is moving the branch point before the block. So unlike in the previous case of rule 3, we have to move the branch point before the block. So what it is mean? What does this mean? You have this G2, you have over here A, and output is AG2, AG2 in both the cases. Why? This is a branch point. Whether you take at this terminal or this terminal or this terminal, the value will be AG2 only. So I have to shift this uh, branch point before G2. So what should I do? So same program representation, like A multiplied with G2, I'm getting the value as AG2. And what I'm going to do, I'll take this branch point before G2, this AG2 kept as it is, and it is shifted over left of G2 like this. Now you see, when you're going to take the branch point before the block, it gets multiplied by A, that is AG2. Simple, when the block is moved from left to right, it gets divided. When the point is moved uh, before the block, it gets multiplied. So this branch point moving from left to right, it is getting divided. Same branch point when it is moved from uh, right to left, it gets multiplied. So that is the conclusion of these two rules. Please keep these two rules as basics in your mind. Now rule number 5, moving the summing point ahead of the block. Now you see you have P and Q. I'm going to multiply it with this G of this summing value. I'm going to get the value as P plus Q of G. So it's the same thing. If at all I want to do, I'll take P, I'll take G, and the value will be PG over here of the summing point. Now another value Q multiplied with G becomes QG, and it is given as input to this summing point, and the parameter it would be P plus Q of G. Now you see this summing point, it is moved after the block G, and when this is done, it gets multiplied. So unlike in the case of rule 3, when the summing point is moved from left towards right, in summing point, in a branch point, it gets divided, whereas in summing point, it gets multiplied. Very important rule. And another rule, moving the summing point before the block means what? You have this block G, whose output multiplied with P will become PG, and Q is taken as a summing point along with this PG, and the value is PG plus Q. Okay. Now what I have to do, I have to take this summing point before G. Unlike in the rule 5, we have taken after G. Now this summing point has to be placed before G. For that, what we have to do? So this representation can be done by taking P in this fashion. Okay, P I have taken directly to the summing point, and Q I am dividing it with G, so that I'm going to get the value as Q by G, and it is giving addition to the summing point. The resultant of these two will result as Q by G plus P. Then I'll take the block G, and I'll give this Q by G plus P as input to G. Then I'm going to get the value as PG plus Q. So the answer is same as this answer, that is PG plus Q. So these rules, especially the rule 3, rule 4, they are about branch point, and rule 5 and rule 6, they are about summing point. These four rules are one of the important rules of block detection. And the rest of the rules you can remember easily, whereas the rule number 3, 4, 5, and 6, you need to keep on practicing in order to solve block detection technique problems. Okay, fine. Now, rule number 7, that is interchanging of the summing points. It is very simple. Like you have parameter x and y given to a summing point results in x plus y, and I'm taking another summing point where you have plus and minus. The resultant will be based upon these addition and subtraction. It will be x plus y minus z. Now, if at all I want to interchange the summing points, mean for I have to uh, take the summing point over here and this summing point over here. Means I have to just change the positions of the summing points. Then what is going to happen? So as you see here, y minus z is taken in one summing point. then the resultant is added with x. So x plus y minus z is the same answer what it is obtained before interchanging the summing points. It's a simple rule. You can remember this rule very easily. Now, rule number 8 is splitting summing points. So you see here you have plus, plus and minus. In one summing point you have three parameters: parameter A, parameter B, parameter C. It is given randomly as the addition subtraction position. So resultant would be A minus B plus C. According to this summing point uh, representation, multiplied with this multiplied with these inputs A, C, B, and added to the summing point will result as A minus B plus C. If at all I want to split the summing points, what I have to do, I'll take A and C separately with a summing point which is shown in this. A results in A plus C, and I'll take another summing point as minus B over here, and the resultant would be A minus B plus C. So the same result I have obtained with the help of splitting the summing points. Then combine the summing points. You see parameter P and R are taken in this fashion. The resultant would be R minus P, and it is given to another summing point of Q in addition. So that result will be R minus P plus Q. So if at all I want to combine them, I can combine them like this. Three parameters R, P, Q, and the resultant would be R minus P plus Q. So this rule number 8 and 9, they are very basics. In fact 7 is also very basic rule. You can easily remember them by keep practicing with these rules. And finally I'm talking about the elimination of feedback loop. If at all you have a parameter G, okay, you will generally call as open loop gain, and it is given as a feedback with H in negative way, then you can eliminate this entire block with G by 1 plus GH. We'll talk about this G by 1 plus GH formulation in our coming classes. As of now, you just keep in your mind, if at all you have a negative feedback, the resultant would be G by 1 plus GH. And another rule of eliminating the positive feedback. So unlike in this case of rule number 10, where you have negative feedback, then the answer is G by 1 plus GH. If at all you have positive feedback, then the answer would be G by 1 minus GH. We'll talk about this important formula of transfer function in our coming classes. Now, since we're dealing with the block reduction technique rules, so we'll stick to this. Now you see in 1998 for 1 mark in gate question, a transfer function C of S by R of S is asked. Now these are the blocks which are arranged here. You have parameters G1, G2, G3, and you have feedback paths H1 and H2. Input is R of S, output is C of S. Where G1, G2, G3 are individual gains, whereas H1, H2 are the feedbacks. Okay, so as of now, this knowledge is enough to solve the problem. Okay, we'll follow the rules to solve this problem, and options were given here A, B, C, D in following ways. These are known as the transfer function. C of S is by R of S nothing but it's known as a transfer function. What is transfer function? Exactly basic details of transfer function we are going to see in our further classes. Um, so we'll go with the solution of this block detection by taking one step. Number one as moving the branch point after G3. Where is G3? Yeah, there is a G3. So we are here to move the branch point after G3. So you have G3 over here, and you before G3 you have one branch point. So this we will shift to the right of G3. So that rule you have to keep in your mind, that whenever a branch point is shifted from left to right, the parameter which is in connection with the G3, it gets divided by G3. So you can see the parameter is H1 here. It is moved from left towards the right. So H1 gets divided by G3. Done. Now this is the important step we have taken. You can also take the branch point which is placed after G3 as before G3. For that the rule would be G3 multiplied with H2. Okay, in the comment section you please Tell me whether you are able to solve by taking the branch point before G3. Now in this particular session, we have taken the branch point from left of G3 to the right of G3. For that, the rule changes to H1 by G3. Okay. Now you see, we can eliminate the negative feedback loop. Where is the negative feedback loop? You can see G2 and G3, they are in series or cascade arrangement. They get directly multiplied, and the combination is having a feedback of H2 in negative way. So with the formula of eliminating negative feedback, you can get the value as G2 G3 by 1 plus H2 G2 G3. So this is a transfer function of this feedback path. So you can easily remove this entire uh, feedback loop with the parameter of G2 G3 by 1 plus H2 G2 G3. Okay, so this is going to be done over here. Now you see we have just replaced that feedback loop, and we kept this G2 G3 by 1 plus H2 G2 G3. Now this arrangement is in cascade, so you can directly multiply G1 with G2 G3. So combining the branch in cascade, I'm going to get the value as G1 G2 G3 by 1 plus H2 G2 G3. Now this combination is again have a feedback of negative in this fashion. We'll go with the same formula of eliminating the negative feedback. So you take this one as the numerator and H1 by G3 as a feedback path. Then you'll be having numerator divided by 1 plus H1 by G3 multiplied with the numerator. Okay. So we can eliminate the feedback path by the formula. So numerator kept as it is divided by 1 plus H1 by G3 and the numerator value multiplied with this parameter. So G3 in this denominator, they cancel out in this fashion. So the final answer of transfer function would be G1 G2 G3 by 1 plus H2 G2 G3 plus H1 G1 G2. Yeah, this is a final answer. So option A would be the right answer according to the given multiple choices. Now let us go with another problem. You can see if the values of G1, G2, G3 are given in some parameters and H is equal to 10, reduce the block diagram and find the transfer function C of S by R of S. So this is like quite previous problem only. So we need to eliminate the feedback path. Before that, we need to shift the branch point from before G2 to after G2, then that would be giving you the final answer, I guess. Okay, so let us move this branch point after G2. So you have this branch point here. So this branch point or takeoff point, we have to move from left to right. So what is the thing which is going to happen? This G1 gets divided by G2. That's the catch. Okay. Now this problem is almost solved here. Why? Because here you have G1 by G2, which is arranged in parallel with G3. Now keep in your mind, this is not a feedback, it's a forward path only. Since you have the starting point which is coming out from G2 and that is going to the block as G1 by G2, and that is given to this negative value. Okay, and you have this G3 coming over here. So I'll take the feedback loop of G2 and H and I'll eliminate this feedback loop, and I'm going to take the combination of parallel, that is G1 by G2 plus G3, and I can eliminate these two forward paths with the summing point as one common parameter. So eliminating the negative feedback loop first. So this feedback loop is removed with the help of the negative feedback formula, that is G2 by 1 plus G2H. Once this is done, you can see this parallel combination can be easily removed with the help of G1 by G2 plus, G3 plus, uh, you have this minus sign. So you have to take the combination of this thing. You can see here I have taken minus G1 by G2 plus G3. Why this minus? Because minus is multiplied with the numerator of G1. That's why it is minus G1 by G2 plus G3. This is one block and this is another block. So we have to combine the blocks which are in series. So the answer would be G2 by 1 plus G2H into this value. So G2 cancels over here. So the response for this elimination or this reduction will be resulting in G2 G3 minus G1 by 1 plus G2H. I hope you have understood how we have reduced the given block to this final value, where C of S by R of S would be G2 G3 minus G1 by 1 plus G2H. Now in the problem, G1 value is given as 5, G2 is given as 10 by S plus 1, G3 is given as 18, and H is equal to 10. Just substitute the values in the formula of the transfer function. So I have taken C of S by R of S is equal to G2 is nothing but 10 by S plus 1. You have G3 which is nothing but 18 minus G1 that is 5 divided by 1 plus. You have G2 that is 10 by S plus 1 multiplied with H that is 10. This would be giving you the value as 175 minus 5S divided by S plus 101. So in the coming classes of control systems, we are going to see some more basics of block reduction technique, and then we'll go with the important chapters of control system, both external exam point of view as well as competition exam point of view. We are going to see all the different techniques of control systems. So please stay connected to the channel for further information, and please share this channel among your friends along with subscription, and please press the bell icon for the future notifications. Thank you.